Most people think AI agents are just chatbots, but modern AI systems can actually reason, look up knowledge, take actions, and collaborate with other systems. The challenge is understanding how all these pieces fit together. In this video, we'll break down a real-world system using one example, and along the way, we'll clearly explain memory, RAG, MCP, A2A. Let's take a realistic enterprise scenario, insurance claims processing. A customer says, "I had a car accident yesterday. Can you file a claim and tell me if I'm covered?" Seems simple, but this requires multiple layers. Understanding policy documents, checking real customer data, filing claims in back-end systems, running fraud and risk checks. This is where AI agents become powerful. The request first goes to an AI agent. But what exactly is an agent? An agent is not just a language model. It is a system that can understand intent, break problems into steps, decide what to do next. In this case, the agent creates a plan. Check if the user is covered, validate policy rules, file a claim, run fraud checks, estimate payout. This planning step is what makes it an agent, not just a chatbot. Before the agent goes anywhere else, it asks a basic question. What do I already know about this user? This is where memory comes into play. What is memory? Memory allows the agent to retain information across the current conversation, past interactions. Short-term memory, session. This is what the user just said. Example, car accident yesterday. The agent keeps this, so it doesn't ask again. Long-term memory, persistent. This is stored over time. Examples, past claims, risk profile, interaction history. Memory helps the agent to avoid repeating questions, personalize responses, use past data for better decisions. But memory has limits. It does not contain full insurance policies, company rules, external knowledge. And that leads to the next challenge. Now the agent understands the situation from memory. But that's not enough. It faces a new challenge. How do I know what the insurance policy actually says? The problem is, this information is not inside the model itself. Large language models are trained on general data. But your company's policies, legal documents, coverage rules are private, constantly changing, and not part of that training. That's exactly where RAG comes into the picture. RAG stands for Retrieval-Augmented Generation. It allows the agent to access external knowledge it doesn't already have. In this system, the agent searches policy documents, legal clauses, coverage rules, claim guidelines. Instead of guessing, the agent follows a structured retrieval process. First, all the documents, like policies and legal clauses, are broken down into smaller pieces called chunks. These chunks are then converted into numerical representations called embeddings and stored in a system called a vector database. Now, when the user asks a question, like, "Is this accident covered?" the agent doesn't do a keyword search. Instead, the query is also converted into an embedding. And the system performs a semantic search, which means it finds chunks that are similar in meaning, not just matching words. From there, the system retrieves the most relevant pieces, often called the top K chunks, and passes them into the model as context. Finally, the model uses this retrieved context to generate a grounded answer based on actual documents, not guesses. So instead of memorizing everything, the model is dynamically looking up the right information at runtime. Think of RAG as giving the agent open book access to company knowledge. But RAG has limits. It does not check this specific user, execute actions, update systems. So it only answers, what do the rules say? Now the agent understands the rules, but another problem appears. Knowing the policy is not the same as knowing the user's actual situation. The agent now needs to answer, is this user covered? can I actually file the claim? This information is not in documents. It lives in real systems. And that's where MCP comes in. MCP stands for Model Context Protocol. Instead of writing custom code for every single database or API, MCP provides a standardized, universal plug-and-play connector, allowing the agent to talk to any tool or system in a consistent way. Systems involved here: policy system, active-inactive; customer database, user details; claim system, create claim; payment system, process payout. Example: get policy, user ID, active; create claim, data, claim created. If RAG helps the agent read, MCP helps the agent do. MCP does not interpret complex documents, make high-level decisions. It only fetches data and executes actions. At this point, another limitation shows up. One agent is trying to interpret policies, detect fraud, assess risk, process payments. That's too much for a single system. So instead of scaling one agent, we introduce multiple specialized agents. And that's where A2A, agent-to-agent communication, also known as multi-agent systems, comes in. A2A allows multiple agents to collaborate like a team. Agents: policy agent uses RAG, fraud agent detects anomalies, risk agent estimates damage, claims agent uses MCP, payment agent processes payout. Main agent coordinates: is it covered? Policy agent. Any fraud risk? Fraud agent. Estimate damage? Risk agent. Instead of one generalist, you now have a team of specialists. When not to use: simple chatbot, single domain tasks, low latency systems. Notice how the system evolved step by step. Agent starts with memory. What do I already know? Hits a gap, needs knowledge, RAG. Hits another gap, needs real data or actions, MCP. Hits complexity, needs specialists, A2A. This is the core idea behind modern AI systems. They don't just know things, they find, act, and collaborate. Final output: your policy covers this accident. Your claim has been successfully filed. Estimated payout is $3,500. And for high-stakes decisions like payouts, the system can also route this summary to a human for final approval before execution. If you remember one thing: memory equals context, what I know about you. RAG equals knowledge, what the company knows. MCP equals action, what I can do. E2A equals collaboration, multiple agents. Agent equals orchestrator. Next video will implement RAG. Stay tuned.